Hey, welcome to our first series of videos for our mole unit. Hopefully at this point you've already made some notes for yourself, you've read over the textbook or watched a couple videos, so you have an idea what the mole is. I'm going to jump right into talking about molar mass and how you calculate it. So molar mass, as the name implies, is the mass of 1 mole of an element or a compound. So if you have a mole of carbon atoms, how much that would weigh, or if you have a mole of water molecules, how much that would weigh. That's the molar mass. So you're going to need to be able to calculate the molar mass so that you can use it when you have to convert from mass to moles or from moles to mass. Okay, so to do that, what you need is your periodic table. Okay, so your periodic table, the version that you have, you're going to find the molar mass sort of at the top. Okay, so you'll notice it's a number. It usually has 3 or 4 decimal places. So that you learned before was the average atomic mass of an element. And it's also the molar mass. It's just that the units are different. Okay, so if you'd like, you can use that entire number that's written on the periodic table. I will be rounding my molar masses to 2 decimal places though. So whichever you choose is fine. I'll figure out what you're doing. Okay, so again, molar mass, what it is the mass that 1 mole of that element or that compound weighs. Okay, so the way you calculate it, let's just dive right into our first example here. We want to know the molar mass of a water molecule. So I'm going to use for molar mass the symbol or abbreviation, 2 capital M's for molar mass. And we're looking for the molar mass of water. Okay, so because this is a molecule, you're going to have to actually add the molar mass for hydrogen together with the molar mass for oxygen. So if you look at hydrogen on your periodic table, element number 1, you'll notice that its molar mass rounds to 2 decimal places to 1.01 grams per mole. Okay, so if you had 1 mole of hydrogen atoms, it would have a mass of 1.01 grams. But you'll notice in the formula for water, it's H2. So what we're going to do is we're going to multiply that molar mass for hydrogen by 2. So it's going to be 2 times 1.01 grams per mole. And to that, we're going to add the molar mass of oxygen, our second element. So it just says O, which means we have 1 mole of oxygen atoms, or if you want 1 oxygen atom. So we're going to add to our 2 times 1.01 grams per mole the molar mass of oxygen, which is 16 grams per mole. Okay, so I'm not multiplying it by anything because oxygen and H2O doesn't have a subscript. Okay, and then all we need to do is add the numbers together. So we have 2 times 1.01 plus 16, which adds up to 18.02 grams per mole. And that's it. So when you're calculating the molar mass, always be careful. I would encourage you, especially as you're getting started calculating them, to always write out all of your molar masses, whatever you're multiplying them by, add it together, and then double check your answers, because it's easy to make a simple mistake, which will then throw your final answer off. Okay, so that's how you calculate molar mass. Let's just do one more example. We have boron trifluoride, which, if you go back to your nomenclature, is BF3. So we want to find the molar mass of BF3. So again, I'm just going to abbreviate it MM, BF3. So that would be the molar mass of boron plus the molar mass of fluorine times 3. So boron on your periodic table rounds to 10.81 grams per mole. Just going to leave my units off for space, plus 3 times 19 grams per mole. Oh, that's 19 grams per mole for fluorine. So 10.81 plus 3 times 19 should give us 67.81 grams per mole. Okay, and then finally phosphorus pentachloride. So that would be PCl5. So it's going to be the molar mass of phosphorus plus 5 times the molar mass of chlorine, which should work out to 208.22 grams per mole. And that's molar mass. So again, as you guys are getting started with your calculations, I would encourage you to write it out and just always double check your calculations, because like I said, it's really easy to make a mistake. Okay, so in our next series of videos, we'll talk a little bit more about what the mole actually is and how to convert between mass and moles and mass.